Hi, my name is John Capobianco, and I'm going to be adding some more tests to our test-driven automation approach using Cisco pyATS. So what we have here is this topology, which has two iOS XE routers that are connected to each other and are connected to two NXOS switches, so different operating systems. There are two Linux hosts, one attached to each of the NXOS switches. Now what we can do is use the ping parser, the parser for ping. And here's the three use cases. From the interfaces on these devices, can we ping public IP addresses? I've used 11111 and 8888. So in this case, I'm saying if they cannot ping those IPs, pass the test. I'll show you where you can easily flip that logic, where if they can ping the public internet, pass the tests. Most infrastructure cannot ping public IPs. That's why I've said pass the test if they cannot ping the internet. Then what we're going to do is from the interfaces, under a certain criteria, ping the Linux hosts or ping a statically assigned IP address. Finally, what we're going to do is discover CDP neighbors in this topology and ping the IP address of the neighbor from the discovering interface. Now what's interesting is when there's a successful ping, we get some dictionary values in the parsed JavaScript object notation, namely success rate, minimum, maximum, and average millisecond response times. So as long as there's one ping that goes through, we get those values. If no pings work, then success rate is 0, and we don't have access to those statistics. So let's take a look at some resources, and then we're going to look at the code, then we're going to run the code, and look at some output and some log files. So, what I want to show you here is that this code is available on the DevNet Automation Exchange, pyATS_ping_tests, has all of the instructions as well as the sandbox that you need, and I'm going to show you the sandbox. You can view it on GitHub and clone the repository and spin up the sandbox and run it for yourself as is, or maybe fork the repo and set up your own ping tests. Now in the sandbox, we want to get started with sandboxes, and what we want to search for is CML, and we want this Cisco Modeling Labs Enterprise, which will give you this sandbox with the CML, and most importantly, this topology with the two routers, the two switches, the two Linux hosts, as well as all of the IP address information that you need. Now the parser that we're going to be focusing on under the available parsers, this will just take a second to load all the parsers. If we search for ping, you can see we can ping an address, or if we dive down a little bit, we can ping an address and specify the source and the number of pings to send. And as you can see, we get this nice structured JSON back, which then we can test against. Now, depending on the operating system, it might not be repeat. On NXOS, it's actually count. So if I switch this to NXOS, you can see that it's count and not repeat. Similar to Junos, it's count and not repeat. But that's fine. We can handle that with some logic. So let's take a look. First, we need a testbed file. And I described the four devices in the topology, specifying their device name, their operating system, their credentials, and their CLI connection over SSH and the IP address. So that's key. We need a testbed file. We also need a job file because we want to run this as a pyATS job. And the function of this job file is to abstract some of the complexity. So I load up that testbed file, and then I load my Python logic and execute it as a runtime task. So a standard job file, pretty straightforward. And then we have our Python logic. So as you can see, I'm importing very little. I'm bringing in JSON, time, logging, AE-test from pyATS, the banner from the pyATS utilities, and a package called tabulate, so I can make nice tabular tables in my logging output. I set up my logger as log, so I can do something like log.info and send a message to the CLI or to the output. And then I have my standard setup. So a pyATS job has a common setup, the test cases, and then a common cleanup. So let's look at these tests. So my common setup, really I connect to my devices, where I just say testbed because my job file has handled that and loaded it in as testbed.connect. I'm suppressing the standard output logging so that all we see are my test logs. We don't see all of the CLI commands and connectivity. You can remove that. It's up to you how much you want in your log file. If you want all of the raw output or if you just want the bannered logging facility. Next, because I have 4 devices, I want to loop each of my tests over the 4 devices in my testbed file. In pyATS, that's using AE-test loop.mark. So mark these 4 classes to be looped over the testbed.devices. And on each iteration, set up the device name as the current device we're iterating through. Okay, so that's my common setup. Now, originally I had just instructions on how to set up CDP, and then I had a second thought, why don't we just automatically set up CDP? So what we're going to do is set up self.device equals testbed devices device name. So now self.device is something from the testbed, the individual device we're iterating over, where we can Pythonically use pyATS commands on self.device, and I'll show you that in a second. Well, first we need to set up CDP globally. So we can check if self.device.operating system equals iOS XE, then use self.device.configure and say CDP run. Else, if it's NXOS, self.device.configure CDP enable. So now my 4 devices globally have CDP enabled on them. The next thing we need to do is go over the physical interfaces and turn on CDP. So again, I'm filtering to say if the operating system is XE. Well, let me take a step back. First, I'm setting up a variable called interfaces, which is self.device.parse show IP interface brief. So now interfaces is a JSON dictionary that I can loop over and say for each interface in interfaces interface key.items, depending on the operating system, if gigabit is in the interface, the string gigabit, then use self.device.configure and set up a formatted multi-line string here that has interface, that iteration of the interface, then the next line, CDP enable. On the NXOS, if it's Ethernet in interface, then do the multi-line formatted string to enable CDP. I'm using a sleep time here of 15 seconds because CDP takes a few seconds to establish all of the neighbors in the topology, and I don't want to start testing CDP until CDP is actually enabled. This might be an optional step. It's more of a safety net just to say, give it 15 seconds once you've enabled CDP to let all the neighbors come up. So that is just enabling CDP. Now let's take a look at the test cases. And we'll talk about the CDP test case at the end. But for public IPs, I'm setting up an AE-test test case. And again, we're setting up and we are connecting to each, we're setting up self.device, the individual device as the iteration of the testbed devices. And then I'm pinging either 1111 or 8888. I'm creating the output files of the results of that ping test, and then I'm testing the success rate of those ping tests. So again, don't be intimidated. It looks like a lot of code, but it's not much. There's not a lot going on here. I set up my number of pings as arbitrarily 5. And then I have my ping results as an empty dictionary, which I append the individual device to it. Depending if it's iOS or NXOS, I set up my interface list, parsing show IP interface brief, and then for each interface, in the interface list interfaces.items, set up a variable called parsed ping, where I device.parse, and then a formatted string here where I say ping my public IP from the source of interface and repeat it based on my number of pings repeating value. Now, why I'm doing this as a try except, as you may know or may not know, certain ping tests will fail if you're not in the right VRF or if the interface doesn't have an IP address. There's different conditions where the ping won't even send. I don't mean fail as in we won't get any response back from the ping. I mean it will fail to execute because of certain conditions. So I set up a try and except. And if it is an exception, then log it out to the screen and say that the interface cannot ping 1111. Now I'm setting up my results here. You can see, right, there's my results that I had as an empty dictionary. Well, I append the interface and then I attach the parsed ping JSON output. It's similar for NXOS, except in this sandbox, NXOS has a few SVIs. So I have an extra little tester here to look for VLAN in the interface, and then I have to go deeper into the dictionary. But I'm achieving the same thing, pinging that device. And as you can see, I have count instead of repeat because it's NXOS. So ping 1111, ping 8888, create the files with those outputs, and now that we have the JSON, let's go ahead and test it and build a table using tabulate in our results. Now there's a couple of little flags in here. One is an empty dictionary, failed success rate, and one is a Boolean variable set to false for no ping response. So if the success rate is 0, flip that no ping response to true. If it equals 100, oh, and I have to flip this logic here. Yeah, if it actually, what I should have is, I've kind of changed this logic with addressing this. If the success rate really is greater than 0, then fail this test. Else, pass the test. And I need to move this logic here, there. Okay, so, and that's my particular use case. If it's equal to 0, then have no ping response. If it's greater than 0, fail this test and add the string failed to this empty dictionary. Otherwise, pass the test, right? So, yeah. Then what I'm doing here is saying if self no ping response is true, then pass this test. Else, fail the test. So we do that for 111 and 888. That's statically assigned IPs where we're just measuring success rate. Now, what about the Linux hosts? Well, we're basically doing the same thing. Ping those two IPs, and there's a little bit of extra logic here. I'm specifying the IP range to ping it from. If it's in the 172.16.252 subnet, if that's in the IP addresses in the parse show IP interface brief, then try to ping it. And it should work because it's in the same subnet. Actually, I'm just going to adjust that to be 172.16. So, right, go ahead and ping the Linux IP from any interface that starts with 172.16 in the IP address field. Do that for the two Linux hosts, create our files, so we have the JSON output of those ping tests, and then I'm testing success rate, minimum millisecond, maximum millisecond, and average millisecond. So let's just quickly take a look at some of this, right? I'm just saying, if the success rate is 0, then change this flag to true. There was no ping response, and we'll come back to why I'm doing that in a minute. If the ping response test is 100, then add pass to the table. If it's not equal to 100, then make it a failed test in the table and append, right, and then set the value to this empty flag up here. So then we determine, should we pass or fail the test? Well, it will fail if that flag has any value set in it. So if any interface that we're testing from does not have a success rate of 100, fail this test. Otherwise, pass the test and set the message accordingly. Right, an interface has less than 100% ping against that IP, or if it passes, all interfaces on the device had a 100% ping against that static IP that we've set up. You could change this IP right up in the tests here. Just change the IP you want to ping, and this test will work for you. So that's the success rate. Now, what about minimum millisecond? Well, if no ping response from the success rate was set to true, then just log out the info, right? The ping failed, no minimum millisecond to measure. Otherwise, check the minimum millisecond against a threshold that we set, and I've arbitrarily set 5 as the minimum millisecond. And if the actual is less than or equal to our threshold, pass the test. If it's if it's greater than the minimum threshold, fail the test. Now in this case, we could fail the test because we're above the minimum threshold, or we could fail the test because there was no ping response at all. Otherwise, pass the test because every interface on the device is within the threshold. So we do that for minimum millisecond, maximum millisecond, and average millisecond. Now the last test case is coming back to the CDP neighbors. So what we want to do is parse, show CDP neighbor detail, and then for the neighbor and the value in the index.items of the self CDP neighbor list, for each entry in the value entry addresses, for every IP we found on the neighbor, try to ping that from the local interface. So the local interface that discovered the neighbor, try to ping it. And then we make our files. We test success rate, minimum, maximum, average. So I don't believe that Python is all that complicated. It's a good use case to get started with. So now let's run the code. So what we're going to do is set up a virtual environment, and we'll just call this ping tests. We're going to activate that virtual environment. we're going to change into our pyATS ping directory and then pip install pyATS full. And this will just take a second to install pyATS full. And then we're going to pip install tabulate. So we have the tabulate package. And then we're going to say pyATS run job, pyATS ping test underscore job. Now, this job takes a little bit of time because of the number of pings that we're sending. We're sending 5 pings from each interface, and we're waiting for the response. So we know it's not going to be able to ping the public IPs, or it shouldn't. That's going to add some latency to this job. What I'm going to do is let the job run to completion, and we'll come back and look at the logs from top to bottom in the CLI and with the pyATS log viewer. And we'll also explore the JavaScript object notation of the ping test, so you get a sense on what the JSON looks like. Okay, the job is done, and we're going to look at the logs in a second. But let's look at the artifacts first, so you get a sense on what a parsed ping output looks like. So let's take a look at the public IPs. So what we have is from each of the interfaces, because of the way we're appending to this dictionary, we have our ping, the address we're pinging, the number of pings to send, the result per line, the source IP, and the statistics. Now the statistics are minimal because we didn't receive any pings. So let's look at a ping that actually worked. So you can see here, what we get is the round trip, average, max, minimum, which we can follow up with tests. So what we can do is, if there's a successful ping, test the success rate and test the round trip millisecond average, min, max. Right, and we have all of this wonderful JSON as artifacts for each ping against each address for router 1, router 2, switch 1, switch 2. Now if we look at the CDPs, I capture the CDP neighbors. So these are the raw CDP neighbor parsed output, and we can see we have 6 CDP neighbors, and here the entry addresses and the local interface. So can we ping the entry address from the local interface? But if we look at the ping test, and let's put this up side by side, where we have 6 neighbors, but how many pings did we test? Well, we actually only tested neighbor 2, neighbor 4, and neighbor 5, because again of those limitations of the VRF that the interface is a part of. Now, what we could do is scroll through the logs and see it from the CLI, but as you can see, we have some failed tests. And you can see at the highest level, it will show the failed, and then per test, which tests failed. But I like to look at it with the pyATS logs view command, and let's look at the latest job. And let's collapse all of this stuff so we can take a look at a high level. So we can see that we have enable CDP all passed, the ping public IPs passed, but the ping the Linux hosts failed, and some of the CDP neighbors failed. Now if we look at the ping public IPs, we have the ping, and here is the ping. And you can see that none of these are successful, which is a pass in our test case. Then we have the tabular view for those tests, and this is why I use tabulate. So you can see from each of these interfaces we're trying to ping, we have a 0 success rate, and that's the past reason the device type router cannot ping 11111. So this section passed. Now let's look at the failures. So if we ping the Linux host failures, you can see all of the breakdown. So the success rate was 100. It didn't fail because of the success rate. you can see that we have 100% success rate on each interface. So why did it fail? Well, it failed because of some of our thresholds. So you can see we have a minimum threshold of 5 milliseconds. Well, this interface failed because it was 9. This interface failed at 7, and this interface failed at 8. Similarly, the maximum millisecond time, right? Everything passed, but this one interface was up at 16 milliseconds, which is 6 milliseconds greater than our threshold. And then our average times as well. So this lets us look into, is it congestion? Is it buffers? Is there something wrong? Why are we above these thresholds on these particular interfaces? Now this HTML file can be emailed or attached to a WebEx or part of a Git repository, and we have our logs, we have the actual JSON output, and we have the results of our tests. Now for CDP, again, it's a minimum threshold. This one interface was at 2.5 milliseconds, right? Is there something going on here? Now imagine actually doing this at the CLI. Imagine logging in to all of these devices and trying to do these ping tests and record the result and then figure out if it's above or below your thresholds. That's a lot of work. That's why we're leaning on automation. So thank you for watching the video. I really enjoyed writing this code. And so again, what do we have for examples? Well, I have examples of testing counters. I have examples of testing strings, full, half duplex, examples of intent in YAML compared to actual, and now some tests using reachability / connectivity testing using the ping parser. So clone the repo, give the repo a star, reach out if you have any snags. It works with the CML Enterprise always on, or not always on, but reservable Sandbox from DevNet. Just reserve the Sandbox, get the VPN up, give it 5 or 10 minutes, make sure you can SSH into the 4 devices, and run the code. You can take small test examples and change it to different public IPs, different private IPs, CDP neighbors. Use it freely, clone it, and start writing pyATS, test-driven automation, ping tests. All right, we'll see you soon. Thanks again.